We're going to talk about something called Pascal's Triangle and Binomial Theorem. So I'm going to start it off with some examples of past problems we've done. So for example, if they gave us something like x plus 4 squared. Now a couple ways we can do this, but the biggest thing you have to do first is that exponent 2 means write it out twice. So x plus 4, x plus 4. And we're not going to finish the problem, but I want to show you that you can either use your box method or you can FOIL this out, but that's not too bad. Let's imagine they stepped it up a little bit and ask us x plus 6 to the power of 3. Now this means you would need to write it out 3 times. It gets a little bit more difficult, but still not so bad. I would multiply that out and then multiply the last x plus 6 in as well. Now what happens if they gave us something like x plus 2 to the power of 6? That means write it out 6 times. 1, 2, 3, 4, 5, 6, and have to multiply that out? Now that's not something we want to sit there and do by hand. What we're going to use is something called binomial theorem. That's going to take, you notice inside of all these are binomials, and will help us, no matter what exponent they give us, to get to an answer a lot faster rather than having to multiply it out. Now what we're going to have to use is a little tool called Pascal's Triangle. Alright, Pascal's Triangle looks like this, and you can continue on forever, but basically the outside edges of this triangle are always made up of 1s. Okay, so we've got 1s going down the sides. The numbers inside are created by adding the 2 cells above them. So like the 1 and the 2 made a 3. So here the 2 and the 1 are going to make a 3. And I'll continue down this. The 1 and the 3 make a 4, 3 and 3 make 6, and here makes a 4, and this continues downwards. So 5, 10, 10, 5, 6, 15, 20, 15, and 6. Okay, this can continue onwards, but we're not going to really see problems that require too many rows down. And speaking of rows, here's how I'd like you to label it. Alright, so up here, this is row number 1, or sorry, row number 0. Row number 1, row number 2. Okay, so it's a little off. We got to start at 0. Row number 3, I'll say number 4, number 5, and number 6. Okay, so this here we have our Pascal's triangle up until row number 6. Alright, because beyond that we really don't need too much. Okay, and when we talk about row numbers, this is all dependent on the biggest exponent that our problem is going to have. Okay, so this is x0, x1, x2, x3, x to the 4, x to the 5, and x to the 6. And you'll see what this means in a little bit once we start our problem. Okay, so this is Pascal's triangle. These numbers are going to help us, and we're going to look at them by row number. So our first example that they're going to give us is x plus 3 to the power of 4. Alright, now again, the exponent 4 means that I would write it out 4 different times and have to multiply it out, but I don't want to have to do all that. That's time consuming. So what we're going to do is use Pascal's triangle and these patterns that I'm going to show you to get this answer a little bit faster. So we look up here. This tells me what row to look at, row number 4. So I'm going to take row number 4, and it's going to be this row here, take those numbers, and I'll write them down. 1, 4, 6, 4, and 1. You'll notice that there are 5 numbers. That means there's going to be 5 terms in my answer. These things are what are called coefficients. They're going to be the front numbers that'll help us find the answers of the 5 terms in my final answer. So whatever the exponent is, there's going to be 1 extra term, one more term in the answer. All right, so we're going to leave those for a little bit. Up here, I'm going to always refer to this as the first piece and this as the second piece. So first piece, second piece. All right, and just like I told you, there are going to be 5 terms to this answer. So what we're going to do is write the first and second piece 5 times. Okay, so stay with me here. We're going to write, I like to put them in parentheses, x and 3. Okay, there's one set. X and 3, there's another set. X and 3, there's a third set. A fourth set. And a fifth set. So we have 5 sets of the first piece and the second piece being multiplied together. And you can go in any order you want now. For this time, I'll go ahead and go with the coefficients. So I'm going to stick each of these coefficients in front of these chunks. So 1, 4, 6, 4, and 1. So these coefficients I put into my answer. The other part that I need to do now are the exponents. The first piece starts at the biggest exponent that we have. So this first piece, x, starts at 4, and then each x after that works its way down. So 4, this x gets a 3, this x gets a 2, this x gets a 1, and this x gets a 0. The opposite thing happens for the second piece. The second piece starts at 0 and works its way up. So 0, 1, 2, 3, and 4. The last thing you check for is the sign in between. And if it's a plus sign, then everything is going to be plus signs. We'll see a minus sign a little bit later. This technically is your answer. What we're going to do is clean this up so it actually looks like a full, complete answer. And the way we'll do that is to start by getting rid of some of the extra things in here. So first of all, anything with a 0 power is a 1, and multiplying by 1 doesn't really do anything. So anything with a 0 power we can get rid of. So 3 to 0 and x to 0 we can get rid of. And now we're going to look at this chunk by chunk. Alright, so here's my first chunk. The 3 to 0 is gone. I've got x to the 4 times 1. That's just x to the 4 plus my next piece here. Alright, so I've got 3 to the 1 power, that's a 3. And you know what? We're going to write out multiple steps here. So let's go 4, that's x to the 3rd, times 3. And you'll notice we'll have a little bit more multiplying in a second. Let's go third chunk. So we'll have the 6, x squared, times a 9. Plus fourth chunk, the 4, x to the 1, 3 times 3 times 3 is a 27. And then finally, plus my last chunk here, 1 times 3 to the 4th power, 3 times 3 times 3 times 3 is going to come out to a 81. So if you're able to do all that multiplying in your head, that's fine. I'm going to go ahead and add an extra step in here just because we still need to multiply a little bit more. You see this 4 and the 3 would come together. So we've got x to the 4th plus 4 times the 3 makes it 12, x to the 3rd. The 9 and the 6 make a 54, x squared. 4 and 27, not something I know off the top of my head, that's a 108, x, and then plus the 81 at the end. So there, everything is in standard form. Biggest exponent, the smallest exponent. It's got the 5 terms. That's what you would get if you actually sat there and multiplied all 4 of those pieces out. So we'll get a little bit faster with these as we go through more examples of them. But basically, Pascal's triangle gives us the coefficients, and then we follow the patterns of the binomial theorem. For example, let's see another one. Let's say x plus y to the power of 5. So this time, just variables, which is okay. It's still a binomial inside, still a 2-piece inside. What this one is asking us to do is to take each piece and write them out 6 times. Because of exponent 5, we're going to write 6 of these pieces. Don't really need parentheses because they're all letters here. So xy, 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 4, 5, and 6. The exponent tells me I need to look at row number 5. And I'll go ahead and scroll back up. Row number 5 now is this one here with 6 terms. 1, 5, 10, 10, 5, 1. So we need those numbers 1, 5, 10, 10, 5, and 1. Those will go in front of here. 1, 5, 10, 10, 5, and 1. Exponents now. The first piece goes from high to low. So high is 5, 4, 3, 2, 1, 0. The second piece goes from low to high, 0, 1, 2, 3, 4, 5. And you notice no parentheses needed this time because everything is just letters. It's a plus sign, so everything's going to be positive in here. Now really the only thing we can clean up would be the y to the 0 and the x to the 0. And maybe just get rid of the 1 exponents that really don't need to show up. So we've got, from here, we've got x to the 5. Here we've got plus 5x to the 4 and a y. Plus 10x to the third y squared. Plus 10x squared y cubed. Plus 5xy. And finally, plus y to the 5. Oops, I missed something. There it is. Y to the 4 plus y to the 5. Alright, so again, that one a lot faster. If we tried to multiply that out 5 different times, probably wouldn't get here for a while. Okay. Check out another example. Let's say it says 2x minus 4 to the power 4. Ooh. Now notice, first piece is 2x, keep it together. Second piece is positive 4. The minus sign is going to do something later. Keep that separate, okay? This is a minus sign separate from the 4, okay? So what this means is we're going to look at row number 4. Let's grab those coefficients from all the way above here. So row number 4, we're back to this one here. 1, 4, 6, 4, 1, 5 terms. 1, 4, 6, 4, and 1. So we're going to write these out 5 times. So now I do want to parenthesis these. We've got 2x and 4. Leave the minus sign for something else. 2x and 4. 2x and 4. 2x and 4. And then one final time 2x and 4. I'll go ahead and put the coefficient numbers in 1, 4, 6, 4, and 1. And remember the patterns when it comes to the exponents. The first piece starts up high at the exponent 4, works its way down 3, 2, 1, and 0. The second piece starts at 0 and works its way up 1, 2, 3, and 4. And now it's the minus sign's turn. We didn't deal with that with the 4, we're dealing with it now. So what happens, and we'll make a little note right here, subtraction makes the terms alternate signs. Okay, so the first one's going to be positive, second one's negative, positive, negative, positive, and so on and so forth. The next one would be negative, positive, negative, positive. Okay, so negative sign alternates them. Negative sign alternates them. All right. So here we go. Let's go ahead and simplify this up. Let's go piece by piece. Get rid of the exponent zeros first. All right, so up here, I've got to now distribute that exponent 4 to both pieces inside of here. So I've got a 1, 2 to the 4th power is a 16 x to the 4. The other pieces are gone, minus. Keep the 4. So this piece here now, 2 to the 3rd power is an 8 x to the 3rd. Still have that 4 to the 1 power, which is just 4. Next piece, 6. 2 times 2 is 4, x squared, and then this 4 squared is a 16. Okay, so this time it might be advantageous for us to write out all these terms. Minus 4. That doesn't change anything, 2x. 4 to the 3rd power is a 64. Plus, finally, a 1 times a 4 to the 4 is a 256. So now let's do what we can to clean all this up. Just a little bit more multiplying now. 1 times 16x to the 4th is just 16x to the 4th minus 4 times 8 times 4. 4 times 8 times 4 is a 512. We still have the x to the 3rd. Plus 6 times 4 times 16. 384 x squared. 4 times 2 times 64, that's a negative number. 512 again. Still have that x. And finally plus 256. So again, we would have gotten there by multiplying it all out, but this, if we just follow the pattern, gets us there a little bit faster. One last example. It's a little bit different problem, but we're going to keep the same kind of process up here. What would we do if the problem said find the 3rd term in the expansion of 5x plus 3y to the 3rd? Basically, when it gives us a problem like this, they don't want us to do the whole problem. I mean, you can, but they only want us to find the 3rd term. Okay, so it's going to come out to 4 terms. It's going to come up to 4 terms. They only want to know what the 3rd one is. So once we kind of find that 3rd piece, we'll just focus on that. So let's go ahead and do that. It's going to be 1, 2, 3, well, that's the 3rd term there. There would be a 4th chunk. Okay, so in it goes 5x and 3y. Okay, so this is my focus one. This is my 3rd term right here. I'm not going to fill in the rest because I don't need everything else from the rest. I just need the kind of the help with the patterns to figure out the exponents, because the first piece, remember, starts high at 3, 2, 1, 0, and the other one starts low, 0, 1, 2, 3. Okay, again, I'm just focusing in here. I see it's a plus sign, so it's going to be positive because sometimes it might come out negative. The only other thing I need is the exponent, so I got to look back up to row number 3. So row number 3 would go 1, 3, 3, 1. So I can just fill it in here. 1, 3, 3, 1. So again, my whole focus is going to be this piece here. So I just need to solve this piece out. Okay, not the whole thing, just that piece. It's asking for the 3rd term. So I'll keep the 3. This is 5x. This is 9y squared. And then finally multiplying all of this together, a 3, a 5, and a 9, make 135. Still have the x, still have the y squared. So this right here is the third term if we were to do that whole piece. That is just the third term there that they were looking for. All right.